Good morning. My name is Arch Woodside, and this is lesson 6 in fuzzy set qualitative comparative analysis, or fSQCA. And let's get started right away. And what we're going to be looking at is graphing a complex fuzzy statement. And this is your output from fuzzy set analysis, and comparing symmetric models, or asymmetric models, excuse me. And so we're working with data from this crosstab, and this is that we looked at back in lesson 4. And what we did was actually pull up the data here. We put the data into an Excel spreadsheet. Notice that we have 4 prices, and $1.98, $2.98, $3.98, $4.98, and I think we looked at just the 3 price levels by the 2 expertise conditions, and this is the salesman's message to a customer when they walk up to the counter to pay for whatever they're buying. They're giving a sales message for a new product, and we also recorded whether or not purchase pal was present or not, and then the outcome condition is purchase or non-purchase, the negation of purchase. And so purchase pal is not a treatment condition, it's a measured variable, and or sometimes called a chronic variable, because it's the state of nature in a given context. It comes from something within the context. For example, it could be age of the customer. That would be another chronic variable. The outcome is purchase, non-purchase. And so if this was a 4 by 2 by 2 by 2, this would be 4 times 8. But I think we did 3 times 8, or 24 cells within the data. And this is the conversion to an Excel spreadsheet, and saved as a CSV file. And so we're going to work with this data set in a few minutes, and using the software fSQCA. And this is the output we're going to look at today, one of the outputs. And here you have 2 models, and we were asked to come up with models that accurately predict purchase. And one model was high expertise, PAL present, and low price. And the consistency is 0.93. That's the main thing. The first thing you want to focus on, the consistency. And 0.93 would mean consistency of about 7 to 1. So for example, out of 8 customers, you sell 7 out of 8 times. If you use this algorithm of an expert salesman, PAL present, and low price. Now, say you didn't want to have the low price, and you figure you might make more profit with a high price. I realize there's an ethical issue here, but another model that works is high expertise, no PAL present, and high price. The squiggly line means the negation of price in the first model. And this model is not quite as consistent. The accuracy is 0.84, so that means about 5 to 1 odds. And you can compute the odds from your XY plot. The coverage indicates, for example, the first model was 0.257 for the raw coverage, and sometimes just the raw coverage is reported in papers, not the unique coverage in the middle. But anyway, the unique coverage refers to just the cases that purchase that this model refers to, while raw coverage is an overlap among models in predicting purchase. So 0.257 indicates among the people who did buy, this model applies to about 1/4 of those cases. And the other model is almost has the same coverage, a little bit smaller. So coverage is analogous to R-square in symmetric analysis. And though, the comparison is not one you really want to make because correlations have such serious problems if you look at things like Anscombe's quartet, and we're going to do that in a future lesson about the problems of using correlation for just about anything. All right, so we have two models that are highly accurate. These are the two models that just repeats what's on the left. And so it's real important to do XY plots. Now, this plot doesn't look like much, but here's a plot of the first model on the left. And here you got 13 cases. First of all, you've got cases that are high, with high membership scores in this model of expert, PAL present, low price, and 13 out of 15 cases purchased. So that's odds of more than 6 to 1 that you're going to get a purchase. It's like going into a casino where your accuracy when you play a game of chance is very biased in your favor. And over here is the findings for the second model. And here you got 8 out of 8 cases who purchased who were high on the model. And model 2 is this right here, expert, no PAL, and purchase. And, the interesting thing here is, is that you have low price, well, high purchase, and here you have high price and high purchase. So it's not really a question of what's the price impact on purchase. You have to look at it from a configuration of conditions. What configurations are present that indicates high price will lead to purchase. The same thing with what conditions are present that indicate low price will lead to purchase. So we can also look at the negation of purchase. Now, I didn't write down the number of cases here, but this 0.68 is a consistency index for the model, and it indicates the model doesn't work very well. So the model is not expert. So not expert alone does not predict the negation of purchase very well. 0.68 is well below the benchmark that you want to achieve for a useful model, and the benchmark is 0.8 consistency index, and the coverage is 0.73. So the number of people in the upper right-hand dot is larger than the number of people, is greater than the number of people in the upper left-hand dot. So there's more people who end up not purchasing than purchasing. But again, we want to achieve an accuracy of about 5 to 1, 4 to 1, 7 to 1, and this model doesn't do it. So no expertise alone may be an accurate model. And you do the data analysis, and it did not confirm that model. So look, this is called a truth table. We're going to look at that in a minute. And a truth table is a step in your data analysis. And this is the truth table before you specify the limit of the number of cases in a model. And so this is not specifying the number of cases, and down here on model, you do specify in the bottom. And so say you specify at least 1 case in a model, and that puts out the models that are in the data set, the possible models in the data set. And if you look at the first model down at the bottom here, you have 0 price, that means low price, 0 PAL, that means low PAL, 0 expertise, high expertise, no, it's zero, so it's low expertise. So low price, low PAL, low expertise. You have 18 cases in the model, and the versus the second model, you have high price, zero PAL, and zero expertise, and you have 24 people in that model. All right, so let's take a look at non-buying. Do we have any model that works among the possible combinations of these three conditions: expert, PAL, and price, and for non-buying, for non-purchase? And we do. We have one model that comes out from the data analysis, and this is a combination of low expertise, low PAL, and low price. And the consistency is 0.82, so the prediction is about 4 to 1 that of every 5 cases that experience this model, 4 out of 5 do not buy. Remember, here it's not buy that we're predicting. So here's the plot of that model. We have 14 cases who, out of 16 cases, so that's 7 to 1, did not buy, who experienced this particular non-buy model that I just showed you. And all right, so I just wanted to point out, this is a very nice paper by Olya and Mehran, and published in JBR, Journal of Business Research, in 2017. And it shows, looking at tourism expenditures by 5 conditions, such as safety of the nation, and entrepreneurship, and the amount of freedom in the country, and health. Down here is HELT, stands for health. How healthy is the living conditions in the country, and personal freedom. This is P, free, personal freedom, and this is expenditure. And notice there's 2 arrows, because you have separate arrows, one predicting expenditures in tourism, and the other predicting the negation of expenditures in tourism. So you got 5 conditions, and if you think of 3 levels per condition, you'd end up with what? It would be 3 times 8, 3 times 3 times 3 times 3 times 3, or 243 possible combinations. Now, you should be guided by theory as to which combinations would work, but here it shows a few models that predict that rather well. The consistency is 0.85. Again, that's about 5 to 1 accuracy in the models, not perfectly accurate. But down at the bottom, you have nobody who has a high score on the model, and a low score on expenditure. So this model, which is model 1, shows when they map the results here, the consistency is actually 0.85. It shows 0.76 up here, but the actual output and the XY plot is 0.86. And where expenditures are high, they include Canada, Sweden, Norway, the U.S., Austria, Denmark. So I just wanted to point out an XY plot that had more a range of dots in it instead of just dots in the corners. And this is an XY plot of another model where the consistency is 0.98. But this model actually is not very good. This is model 2, and the reason I say it's not very good is that you have nobody above 0.5 in the about 0.5. You know, Russia is high in the middle, and Saudi Arabia is high right below that. But you don't have anybody in the top right-hand quadrant. And so I would suggest that the model doesn't work very well. And it's very important to look at some XY plots, not just look at the consistency index and the coverage index. So the takeaways from this is that based upon theory, prior literature findings, and your own insight, you write actual statements as to what model will work. And then don't forget to write a separate model for the negation, because it's an asymmetric analysis. We don't predict that high X gives you high Y and low X gives you low Y. They're separate outcomes that you need to predict separately. And so please do include XY plots in your research reports. Now, what I'd like to do is take a second here with you, and we're going to actually do some analysis together on this. And I'm going to pull up the fSQCA, and here's the data file in fSQCA. So let's go ahead and just run the analysis together. And so, and this, we're going to use the analysis command and do a fuzzy truth table. And so we'll look at buy or purchase as the outcome condition, and the three conditions as input: price, PAL, and expertise. And there they are. And you don't need to put the negation in for anything, because the software program will give you negation in a model if it's useful. So now we run the model, and here's our truth table. Now, you need to click on edit and edit and code, delete and code, total there. And you can change this if you want to. Let's go ahead and change it to 2. And we can make this say 0.8884 in terms of consistency. And click OK. And that's the minimum consistency that you're willing to accept for a model. Click OK. And there you get models in the data set. And so here's the situation. The first model would include low price, PAL present, expert present, and there's 15 cases, and it has 0.93 accuracy. One of the 15 cases is indicated not buying. So now you click on standard analysis, and we get the output. And there's the output. Might have frozen up on me here. It says it's not responding. So I'm going to close the program, and I'm going to open it up again, and we'll do it again. Okay, so I'm going to open the data. I'm going to I'll open. By the way, I made a few sets of the data, so if something goes bad with the program and your data is destroyed, you're going to have another data set. So I'm going to run the program again under using analysis, and we're predicting buy, and we're using our 3 conditions: price, PAL, and expertise. And run, and then edit, and I'm going to go with 1 and 0.8 this time. Minimum number in a row would be at least 1. Push OK, And so these are all the rows that where we have data in them. Remember, if we have three of these, price, PAL, and expertise, so that would be at least 8 rows of data. And so we're going to have at least 8 rows of data here. And so here's the analysis again, and hopefully I can do this without it closing, because you can't quite read the output. There, I minimized it. I'm going to open it again. Good, there's the output. And these are the two models that we looked at. The first model is price, not PAL, expertise, and consistency 0.84. And the second one, the consistency is higher, and it's low price, high PAL, in other words, PAL present and expert, and the so it's quite a good model. And let's minimize that, but let's go ahead and model the negation here. So we let's see if we have, we can put in buy here. I like to come up with the data for buy. So before we do that, let's go ahead and do that. That's variable compute, and compute the negation for buy. Bring up the not into the expression line, and then bring up buy, and then we're going to put not buy. Okay. Let me try it again. Variables, compute, not buy. Okay. Okay. And there it is. There's not buy. I'm going to save it, save, and then I'm going to run the analysis to predict not buy. Fuzzy truth table, and predicting not buy using the price, PAL, expertise. Run. There's the truth table. I'm going to delete and code, keep it at 1 and 0.8, and do standard analysis. And there's the output. And we end up with one model, low price, PAL absent, and expertise absent. And that's 0.82 consistency. So the model gives us about 4 to 1 outcomes of non-purchase. And we can actually graph that model, by writing out the model in the data set, and then as a fuzzy statement. And just to check together with you, let's also look at the XY plot for non-expert, I'm sorry, not buy, predict not buy by non-expert. Non-expert case plot. There's the plot, and here, if we click on that, we can see the number of cases in the top right. We have a good many cases. We could count these cases, and we're going to end up with I don't know what the screen in this version of fSQCA only shows 5 at a time, but there's about 35 cases there. And then down below, this is people who have low not buy, meaning that they actually bought. And in this case, we have a good many cases too. And that just points out that not expertise, it does not predict not buying very much, the 0.35. So just giving a message, and what we can do is actually look at what the other items too, price and PAL, to see the effect on not buy. So you got to gain some experience from this and actually working with the data. The one thing we haven't talked about today that we'll talk about in the next lesson, lesson 7, is looking at necessity analysis. Do any of these 3 conditions actually predict as a single condition either purchase or non-purchase? And the reviewers of journals like to see a table on necessity analysis. So I want to suggest to you that please do come to lesson 7, and we'll cover that in lesson 7. So let me just say it's good to see you at at these sessions, and I hope you'll be able to attend lesson 7. And so I'm going to close out now, and we'll see you for lesson 7.